Welcome guys. Today we are going to discuss the Unit 2 Topic 1 in Metrology and Measurements subject, and the topic is Introduction to Linear Measurements. At the end of the session we are going to discuss some objective type of questions. These are the main objective of this unit: to understand and familiarize the various devices used and principle behind linear and angular measurements, to choose a suitable measuring device according to the precision required, to equip with knowledge of limit gauges. This is our syllabus of Unit 2, Linear and Angular Measurements. These are the topics we are going to cover. In this video, we are going to cover the topic 1. Measurement. Measurement is the process of associating numbers with physical quantities. The numbers that is going to show the size or amount of something. In industries, it is for quality control. Widely used measurements are linear measurement and angular measurement. Linear measurement includes measurement of length, diameter, height and thickness of the workpieces, and the angular measurement includes the measurement of angles and tapers in the workpieces. Let's see linear measurement first. It is a screwdriver. I want to know the length of the screwdriver. It can be identified if the distance between the extreme points of the screwdriver. With the help of a scale or steel rule, we can able to measure it very easily. Here I didn't consider the accuracy of the measurement. Please make a note of it. According to the standard, linear measurements are generally classified into line standard, N standard and wave standard. Let's discuss one by one. Number 1, line standard. In line standard, the length is measured between the two lines, that is the engraved lines which is in the scale, and it is a very quick one. Also it is not an accurate one. Here we are having some kind of wear. Also while we are measuring, parallax type of error also going to occur. In this type of standard there is no built-in data. Very popular example of line standard is steel rule. And the next one is N standard. Here the length is measured between the two parallel planes or surfaces or between the two ends. It is a time consuming process. The measurement is somewhat close to the accuracy level, and here the wear rate is very high comparing to the line standard, and there is no parallax type of error. In N standard, built-in measuring datum is available, and the examples are slip gauges and N bars. And the next one is wave standard. In wave standard, we are going to use a monochromatic light, that is krypton isotope 86 is mostly used. That particular krypton isotope 86 wavelength is used as a unit of length. Usually wavelength standards are time consuming one while we are measuring the linear distance, and it is a very highly accurate one. And here there is no wear because it is not a material standard, and the error is very low, that is a negligible one. Based on the resolution, we are having low resolution devices, medium resolution devices and high resolution devices, and these are the example for low resolution devices: steel rule, calipers, divider, surface gauges and some thickness gauges. And micrometer, telescope, vernier calipers, dial indicator, these are medium resolution devices examples. And these are the examples for high resolution devices. They are gauge blocks, gauge block with assistance of mechanical comparator, electronic comparator, pneumatic comparator, electrical type of comparator and optical flats. Surface plate. Basically, the linear measurements starts at a reference point and ends at a measured point. This is true when our basic interest is in measuring a single dimensions, that is length is in our case. However, the foundation for all the dimensional measurement is the datum plane. It is a very important one. One is being the surface plate. With the help of the adjusting lever screws, we can able to ensure the flatness of the surface plate. Generally, the surface plates are made up of solid materials, and it is extremely flat with a tolerance up to micro level. It may vary depends upon the grades of the plates. We are having grade 0, grade 1, grade 2 types of plates are available in the market. These type of flat surface plates are used as a main horizontal reference plane for precision inspection, marking out and some tooling setup. The surface plates are generally made up of cast iron, granite, and some plates are made with the help of some glass materials also. The surface plate must have a good wear resistance and very low thermal expansion property. That is a very important one. Let's see the evolution of surface plate. In 1817, Richard Robert invented the surface plate. He showed a way of duplicating the flat surfaces with a high degree of accuracy. Sir Joseph Whitworth suggested a three-plate method to manufacture this kind of surface plate. Cast iron plates are having good magnetic property. Metal alone used for surface plates until the World War II. At the time of World War II, there was a huge shortage of surface plate in the time. The manufacturer goes for granite, glass, and some ribbed type of cast iron surface plates like this. And graphite is harder than cast iron, and it is more stable at high temperatures also, and it is a non-magnetic one. It is having excellent vibration damping characteristics, and it is not going to rust. Graphite is free from burrs because of its fine grain microstructure. Glass surface plates are also used at the time of World War II as an alternative material for surface plate. Glass can be suitably grounded, and in cast iron plate, burr is a major problem, but in glass, it is easily chipped away. Cast iron type of surface plate is having uniform optical properties comparing to the graphite as well as glass. And the next one is V-blocks. V-blocks are used to hold the cylindrical type of workpieces while we are going to do the measuring process. V-blocks are having some type of clamping system like this. See here, you can able to see some slots. With help of the slots, we can able to clamp the workpiece tightly. Some of the V-blocks are having some magnetic type of arrangements. With the help of a button, it will magnetize and demagnetize to clamp the workpiece. Let's see the linear measurement evolution from non-precision to precision instruments. Generally, linear measuring instruments are categorized depends upon their accuracy. That is, non-precision instruments and precision instruments. Under the category of non-precision instruments, we are having steel rule, caliper divider, and telescopic gauge. Under precision instruments, we are having micrometers, vernier calipers, height gauges, and slip gauges. Steel rule. Steel rules can be flexible or non-flexible. Sometimes it will be a very thin one, or sometimes it may be a very wider one. Generally, the thinner the steel rule, the more accurate it can measure because the division marks are closer to the workpiece. Before going to measure, we have to ensure that the steel rule is clean and dry before storing. We have to use some kind of soaps or mild solvent to clean the steel rule before going to use. Usually in the machine shop, a small amount of oil is going to be rubbed over the surface of the steel rule. by doing this process we can able to prevent the rust formation. The steel rule has to be stored flat in a drawer or toolbox so that they won't get bent and the edges won't get damaged. Rules are produced with help of this type of roll of band spring steels, and then with the help of some laser engraving machine we are going to produce the markings in the steel rule. And these are the available sizes of steel rule in the market: 150 mm, 300 mm, 500 mm, etc. Next one is calipers. Calipers are used for measurement of parts which cannot be measured directly with the help of a scale. See, for example, the steel rule cannot be positioned diametrically across the job with the required degree of accuracy. Thus, these type of calipers are used as accessories to scales. Generally, the calipers consist of two legs which are hinged at the top. The ends of the leg span is used for inspection. This span is maintained and transferred to the scale. This caliper is an example. Spring type of caliper. The spring provides sufficient tension to hold the legs rigid at all points of the adjustment. With the help of a knurled solid nut, we can able to adjust the dimension of the caliper. A small washer under the nut minimize the friction between the nut and the leg. This type of spring type calipers are used for comparing or measuring the hole diameters, distance between the shoulders, or some other parallel surfaces of any dimensions. The next one is frim joint type. Basically, they work on the friction created at the junction of the legs. The two legs are identical in shape with the contact points equally distant from the fulcrum, and they are joined together by a rivet. These are the type of frim joint type: outside caliper, inside caliper, transfer caliper, and hermaphrodite caliper. Outside frim type of caliper is used to check the inner diameter or hole diameter, and inside caliper is used to check the external diameter of a shaft. The transfer calipers are used for measuring the recessed areas from which the legs of the calipers cannot be removed directly but must be collapsed after the dimensions has been measured. An auxiliary arm is provided with the two legs so that it can be preserved the original setting after the legs are collapsed. Hermaphrodite type of caliper, it is especially used for scribing the lines at a specified distance from a flat or a curved surface. The next one is divider. Definitely you know this device from the schooling itself. A divider is simple in construction to a caliper except that both the legs are straight with a sharp hardened point at the ends. And the next device is telescopic gauge. This is used to measure the internal diameter of a hole during the machining operation. That is a very important thing. It consists of a handle, two plungers, one telescopic into the another with the help of a spring tension. The ends of the plungers have a spherical contact. The plunger can be located into the required place by turning the knurled screw at the end of the handle. If we want to measure the diameter of a hole means the plungers are first compressed and then locked in the required place. Next, the plunger end is inserted into the hole and allowed to expand to the opposite edges. Finally, they are locked in place, then taken out from the hole, and it can be measured with the help of a micrometer or some other linear measuring devices. And the next device is small hole bore gauge. It is similar to telescopic gauge. At the one end, it is having a knurled knob. At the another end, it is having a special ball which can be expanded at its end. The ball is spherical in nature. With that spherical ball, we can able to measure the hole diameters. And the final one is depth gauge. This tool is used to measure the depth of the blind holes, grooves and slots. It contains two parts. One is a sliding head and another one is a narrow steel rule. Both are clamped at a right angle. For example, if you are having a component like this, if you want to measure the depth of the slot means you can use this depth gauge. Let's have a quiz session of the above discussed topic. Post your answers in the chat box. And the question number 1. What standard of linear measurement is a fast one? Wave standard, line standard, N standard or ISO standard? Question number 2. Why wear rate is not mentioned in wave standard? Because it is made of hard materials, because the materials are heat treated, many chromatic light source used, it's not a material standard. Question number 3. It is a fill in blanks type. Hermaphrodite caliper are used for dash purpose. Question number 4. Which of the following is the most suitable for wave standard? Cadmium 114, krypton 86, mercury 198 or any monochromatic light? Question number 5. It is also a fill in blanks type. Can you name the instrument name with the help of the given figure? Question number 6. How can you measure the thickness of the bobbin hollow cylinder? Number 1. Scale. 2. Inside caliber. 3. Transfer caliber. 4. With the help of depth gauge. Question number 7. What is the foundation for all dimensional measurements? Workpiece surface, datum point, datum plane, surface stable material. Question number 8. Which of the following is not correct about wavelength standard? Wavelength of monochromatic light is an invariable unit of length. Wavelength standard is a physical standard. It is a reproducible standard. It is a natural unit of length. Question number 9. While fabricating the surface plates, according to Sir Joseph Whitworth's suggestion, how many plates are required? 7, 6, 4, 3. Question number 10. Why granite surface plates are free from burrs? It is very hard than cast iron, not affected by temperature, very fine grain structure. It is a ceramic. Share your answer in the chat box. You can also use the below Google form to submit your answers. If you scored more than 8, it's very good. Otherwise, please once again go through the content and answer this question. Thank you. Thanks for learning here. You can.